Everyone close your eyes if you're watching. It's embarrassing.
You should clip it to your goatee. There you go.
Can you hear that okay, Dave?
Yep.
You have to look at me for the joke.
It's in its goatee.
Is that okay? Okay. All right. So, we hide the beer. The audience is here. Wait a minute, is this on?
Well,
You
I'm
get
gonna
me?
leave the camera mic going since you
Okay.
both of you, otherwise you just got.
Yeah, okay. Cool. All right, we're getting ready to start. What time is it?
Don't know.
420.
4:20. Whoa. That's awkward.
It's California.
Never mind. Let me ask in a minute. We'll just pretend like that never happened. Well, Dave, we're back. So welcome to Printerbot Live on Facebook, and we will post this on Vimeo and YouTube as well.
Vimeo's still around?
Oh yeah.
Wow. I thought
Yeah.
it was dead
I like
years
to
ago.
support all the has-been media options like Google Plus. I love Google Plus, but it's got the smallest audience ever.
Yeah.
Some people don't know about Vimeo, but
Think it's
Vimeo
okay.
actually has a really cool streaming service for this.
Really?
Actually, yeah.
Oh,
So
cool.
Facebook and Vimeo. So I like Vimeo because it's a little more. I hate YouTube and all the ads. Anyway,
Okay, gotcha.
this is what a
That makes
pre-show is. So we're in the pre-show portion. It is now 4:21, and we are not only on time, we're early. I think the last time we did a show, we were also a little bit early. We did a pre-show, and what that really helps is I get all my words out, and I can end a little sooner. So hopefully that'll happen this week.
That didn't happen last time.
Oh wait, it didn't happen last time.
We
Dave
started early
says.
and
What?
Really?
We start. Ugh. All right. We'll try today. So here's what we're doing right now. I wanted to show we have the Ubis 13 HF, which is high flow, in the store. It's for sale.
For sale today.
Okay. So today's the first day. So I thought we would feature.
Special promotion right now.
What is it?
The first 50-ish get a tip pack that goes along with it.
So what tips are included with that? So we throw in some free tips for these
So
early
let's talk about what's
adopters.
installed on it first. So what comes installed on it is a 0.75 millimeter tip.
Okay. Big.
Yep, big, because it's for high flow.
Is that what we got going here?
That's what's going on in stock.
Okay.
And then the tips that you get with the promotional batch, which again is going to be around 50. We'll take it off the website once the promotion ends. So you'll know if you're getting it or not based on the product description. 0.4 millimeter, so standard on what used to be the old Ubis ceramic and Ubis 13S. So if you want to go back down to that finer tip, you can. 1.5 millimeter, so we're going to be
Wow.
going bigger, and an experimental 2 millimeter
Yes.
tip.
I love that one because the filament's 1.75. I'll explain a little bit about how you would use a 2 millimeter tip with a 1.75 filament. But what we did here is I just wanted to show a simple visual demo. So over here, we actually have the same, well, it's the same model, right?
Stock. It was
No,
stock.
no, no, I'm talking about the model that it's printing.
I had a slot. Well, it's the same STL,
Okay. Same
but
model.
it's a different G code.
Right.
Yes.
Because, and here's why. The wider tip over here, this is 0.75 and this is
0.4.
0.4. So this is typical to what you would have installed on your printer because
Yes.
all of our printers up until the Pro shipped with the 0.4
Yep.
and the Pro ships with the 0.3. The Pro is really for people that want very, very high resolution out of the box. So this is a 0.4. So even if you don't have a simple, this is the performance similar to what you would get with your printer if you have a 0.4 nozzle. And it shouldn't matter whether you have a ceramic on one of the old ones with no fan. This is a ceramic. Or Ubis 13S, which is our standard nowadays. This is the Ubis 13 HF for high flow. So it's longer, and the fact that it's longer, what was it, a half inch, quarter inch? I forget how much longer, but we've doubled the melt zone. So when you double the melt zone, you can get more heat onto the plastic, and you can move faster. I mean, move the plastic through faster, so that's why it's high flow. It's actually volumetric flow. In other words, we don't talk about speed in printing speed because you know if you sped this up to the fastest speed that it could possibly do with a 0.4, it doesn't have to move as much plastic as this. So this speed would be slower than this because we're moving more material, and you know that's harder to do. It's the hot end that melts the material. So if you have less to melt over here, it's going to look faster. But I wanted to show this demonstration because this is actually the real world of, let's just compare, forget the tip size is different. It is basically the same bot. It's a different slice because you got to slice it differently for the tip size. But in effect, the total time is much faster. I mean, look, this is on, what, layer 3?
Layer 3, layer 4, somewhere around there.
It's about to hit layer 4, it looks like.
To get to a base layer, total layer height of 1.2 millimeters.
So the bottom of this cylinder is actually 1.2 millimeters. This one did it in a couple of layers.
Just 2 passes because we're doing it at 0.6. You can do 0.6 layer heights for this one. You got to do 0.3 layer heights for that one.
Okay. Now 0.3 layer height's pretty thick for typical printers.
Yep.
So I don't know, you probably can't see this real well. Oh, it's already done, so what's the time? So
9 minutes, 55 seconds.
This was roughly a 10-minute print.
Yep.
And this is just now, I see it. It's getting to, it must have been on the 4th layer, 3rd or 4th layer. But now it's doing the spiral portion. It's not truly a spiral print because doesn't it, or is it?
It's spiral based.
Oh, it's spiral based.
I sliced it with slicer.
So the difference between these two prints will be the wall thickness here. But I guess it's a little more fair to do a spiral print over here as well, because then you don't have travel moves, you don't have multiple passes on the wall thickness. So if you wanted this to be exactly the same, you'd have to dump the spiral print on this, and it would have to do a couple passes.
Two perimeters.
2 perimeters to have the same wall thickness. But
Ish.
the benefit, yeah, I mean, that we're generalizing.
Yeah.
The benefit of going to a larger nozzle when you go to the HF is you get structural strength. So this has got very good layer adhesion, and I'm a little bit scared to pull that off. Spiral prints, typically, they break unless you pry them up from the bottom. Do you have something that I could...
Your left hand should have something.
You want to try to get that off without breaking it? But anyway, so it's not totally apples to apples, but you kind of have to get your head around the different strengths and weaknesses of these two setups. So you can see here, Dave, I don't know if you can zoom in on this. It's kind of like back to the old days where you can see the layer height because it's 0.6.
0.6.
0.6, but it has a certain appeal to it, and it's definitely strong. You've got one pass kind of melting together with the bottom, you know, all at once instead of 2 small passes. But anyway, I think this is a pretty good example of what you're going to save in print time. And that is really the painful part of 3D printing that a lot of people don't talk about anymore. It used to be, I'd show a 3D printer to somebody and their first question was, is it always that slow? And the answer is, yeah. I mean, it's all slow. 3D printing is slow when compared to injection molding or something like that. You know, CNC is even slower because you have to remove so much material and leave just a little bit of material. So this part on a CNC would be much slower. But anyway, but now we're starting to make some progress in printing faster. One is you give up resolution for thicker layers, bigger tips, thicker walls. And on that 2 millimeter, I have a guy with the prosthetic printer, he's using a 2 millimeter tip. He's over extruding like 2.5 on the extrusion multiplier, so that even more is coming out because he's only doing one pass and he wants a 3 millimeter thickness. So he's getting around 3 millimeters thickness with a 2 millimeter tip. But what's kind of cool about that is for his target, you know, what he's using his printer for, it's kind of a one-trick pony. It's a lot of spiral-based stuff, or at least a lot of hollow prints with thick walls. He's using PETG. He's getting great speed. Total print time is low for this type of setup with a 2 millimeter nozzle, HF, the HF with the 2 millimeter nozzle. And if you were to try to do that on a regular printer like an Ultimaker or something, it would take forever. Now, Ultimaker, you can go fast, but it's a very small tip. So again, that tip tends to be the speed. The Ultimaker doesn't even print large enough for him. So larger printers, faster printing, thicker, extrusion that comes out, and faster extrusion is kind of opening up some doors for 3D printing to come into new niches that need specific, they have a specific need, and it's not, a 2-inch tall Yoda head. So a lot of times the 3D printing is just a novelty, and it's something to experiment with. I think it's really good at prototyping. And when you're doing prototypes, you know that the resolution of this will work fine because you're just trying to get the shape, the feel in your hand, or the function, the bolt hole pattern that you want to bolt something to. So it's utilitarian. And resolution doesn't matter as much. If you're willing to give up on that a little bit, then you can really, really lower your print time. So I think that's really cool. All right, so the HF is for sale. You get extra tips. Golly, we're look at the difference. We're how long?
15 minutes.
I guess I'll just stop this. I kind of want to know. Do you want to know? Okay, we'll let it run. I'll just move it over to the side a little bit. I want to show you. One other thing I wanted to say was we did an impromptu. I did an impromptu little contest on Twitter, and I said, hey, 100 retweets or hearts or likes or whatever you call them, and nominate somebody that is worthy of getting a free 3D printer, a Printrbot Smalls base kit. And man, all this community members just kind of showed up and started saying, hey, this guy, this school, this nonprofit, and people were nominating. And then, man, it happened really quick. We got 100 retweets, or the equivalent, just within a couple of hours, just a few hours. And so we shipped out that prize today, and I was going to see if I could find his name. Dave, do you know off the top of your head what his name was? I'll have Dave look up his name because we shipped that printer today. Just wanted to say congratulations. Pretty cool to find out that somebody's designing. He does a lot of work for Wi-Fi geeks, cases, mounts, who knows. But he was doing a lot of design and he didn't even have a 3D printer. So pretty cool. Now we're going to get a designer a 3D printer and hope that he keeps serving the community. What was his name?
Robert, I'm looking for him.
Robert. So congratulations to Robert. We're going to try to do more of those type of contests, which are just like, boom, it's over very quickly. So continue to follow us on social media because those things are kind of fun. And it helps us because we get retweets and stuff. But really, it's just rewarding the community. I don't really care that much if it's selling printers. But it was nice to see that there were a lot of people that wanted a 3D printer that didn't have one. So that's a little bit encouraging. But anyway, I wanted to mention Robert. So Robert, congrats, way to go, enjoy. And thanks to Joel for nominating him. I'm going to set this aside, make room on the table. A little bit of a surprise. All right, when that stops, let's look at the... Oh, well, what's your timer at right now? Because you might want to take off.
17 minutes. 10 seconds.
Oh, where is it? Stopwatch. Stop. Reset. Start. 17 minutes what?
20 seconds.
Okay. So roughly 17 minutes. So Dave will add 17 to this. All right. So before Jeremy takes off, by the way, come here, Jeremy, just for a second. Jeremy, I wanted you to meet Jeremy. Some of you guys have met Dave. And Jeremy Gallegos, he runs the shop here, so he's not just a friend, but he's a great worker. And
Yes, I am.
yeah, he's the local comedian around here, but be glad you don't have to hear his humor. Anyway, but I wanted you just to meet Jeremy. Looks like
Try to look like Brooke.
the beard. I don't know what I think about the beard. It's a little bit Jewish rabbi.
My wife's grandma calls me her rabbi. There you
That's
go.
beautiful.
Yeah.
It's a teacher.
Yes.
Anyway, Jeremy's great to have around the shop because he keeps things light. Great guy, does a great job, and he has strengths where I have weakness. I don't know if this is obvious to anybody that's followed Printrbot for a while, but I'm really bad at details. So I heard you laugh just now.
No, that was the audience.
Oh, I didn't know I could. Is there a speaker? Anyway, so it's good to have just admit your weaknesses and surround yourself with people that have strengths where you are weak. So Jeremy, glad you're here, man. Thanks for all your help. All right, is this just one of the okay. I'm going to bring something up on the table here. Dave, adjust the camera as needed. This is going to be kind of cool. Check this out. All right, Jeremy, will you help me with this? Of course, I get the heavy end. Of course. You might have to back this thing up. All right. What is this? Can you see it? Okay, so this is Total Alpha. This is something that we did a few months ago, and it's actually a I don't know that they're calling all of their stuff this right now, but I haven't really named it. But this is taking 3 simple pros, and what we did was we got in touch with Autodesk, and they got in touch with us, and we started talking about the possibility of us making one of their Escher printers. So their Escher printer is, I don't know if there's a link or anything, but just Google Escher, like MC Escher, on Google, and you'll see some videos of this crazy big printer that they did. They invited me down to see it in their secret lab quite a while ago. Might have been a year ago. And it was this very, very complicated, very, very expensive, but very, very cool printer that used multi-gantry printing and some very special software that they had been working on to slice the print up into different sections and dovetail them together. Each section would have one print gantry, which is essentially a complete 3D printer. And these multiple 3D printers would work on one print at the same time. Now, when you have an overlap of this, what I call dovetail, but it's not really a dovetail. It's kind of this randomized layer overlap. Sometimes these printers can't get, infinitely close together. They can't print on the same line. So they have an overlap, and one printer will move over here. Well, if this printer came over here, it would bump into it. So in order to have all the gantries operate independently, they had to have a brain that keeps track of where everybody is. They call that the conductor. So there's a piece of this software that would kind of direct traffic. It's a conductor. And so each printer would get a portion of the overall model. It would be a slice, and the printer just knows that it's what it's supposed to do, and it thinks, this is the print, and it does its thing. But during the print, it would wait while the other one overlaps to stay out of the way, and then it would resume. So you have multiple printers, 2, 3, 4, 5, 6, 7, however many you want, and the conductor is a Raspberry Pi to direct traffic. Each printer has a Raspberry Pi with special software installed. So each printer is taking their slice and it's streaming live. So the conductor can keep track of everybody and direct traffic. Now, going back even further, it's actually right now just a Windows computer, and they bought NetFab. So I've used NetFab since the very beginning to repair my prints. It's a great product. But they added some functionality to it to slice these large models in a way that ends up with multiple files that you can then transfer to your conductor and therefore each of your printers. So if it sounds complicated, it's because it is complicated for the software programmer guys. But they've been continually improving each revision. They've been improving this constantly, and they are great guys to work with. Corey's fantastic. And so we are one of the few companies that have signed on to make an Escher printer, for lack of a better term, so PrinterBot Escher. And I make small printers. I make fairly inexpensive printers. We're kind of in the middle ground. We're not cheap Chinese. We're like, American quality. And so we land somewhere in the middle. We don't try to say we're the highest resolution, fastest, best printer for professional use. Although, when you look at our prints, it's very similar in quality, if not just as good or better than the competition. So it's 6 minutes plus 17, so that's 23 minutes So we had a 10-minute print and a 23-minute print with a regular setup. You can see the resolution. You don't have to zoom over there, but the resolution is a little bit higher on this stock setup, but this feels stronger because the wall is thicker. So anyway, that's our conclusion of our little impromptu test there. Back to Escher. So anyway, we're a good partner to have because we can prototype everything in-house. So we slapped this together. I say slapped it together. I mean, we took a couple weeks. But we made this printer from parts we had in our shop. We used the Pro. We put printer boards on it. We made some new parts. So these three, and this was a working printer, but I tore it apart because I want to show you one other thing. So these, we printed this. Jeez, beautiful. We just stretched the PrinterBot logo out to ridiculous lengths. And I did it in black on the ends and white in the middle, so you can kind of see how the joinery happens here. It's kind of obvious. You can kind of see it. Now, we also used 1mm nozzles just to go fast. I don't even know why I chose that. It was just what we were doing. So this was with the UBIS 13S, so it doesn't have near the throughput as that one. It's roughly 2.5. That's not fair. But anyways, the HF would be a lot faster, and I'd probably dial down the tip size so that you get a little higher resolution. When I say resolution, when you take a 0.75 tip, you've got this round, hole. And if you paint, it's kind of like drawing with a big magic marker. You can't get the edges really sharp. So some of these edges, while it doesn't bother me, they would be slightly rounded off where a smaller tip size would be a little more crisp. Other than that, and the layer height we chose, I think the HF would be a good match for this, but people may want high-resolution prints. But anyway, back to the print. So we printed this, and I truthfully don't even remember how much is printed, but I remember when it was done, Mick and I were shocked at how fast. It was a couple hours, less than a couple hours. But we were shocked at how fast it printed. It was just laying down the plastic. And it was really neat to see it, cooperate with the printer beside it to trade off on these areas here that overlap. And this was, like I said, quite some time ago, and it's gotten even better. So Netfab, they've bought Netfab, and they've got this crazy slicer capability built in with Escher. And we've signed what's essentially like an agreement with Autodesk. Now we can talk about it. And they actually liked this printer so much, they were like, yeah. Like desktop printing would be really cool because some people are building very, very large printers, like feet by feet by feet. And it's kind of neat because it does scale up to whatever you want. The slice doesn't really matter. It doesn't really care how many printers you have or gantries and how long it is. But we just took what we had in-house to get a demo working. And this still just has the 6-inch throw. I think it's 4 feet long, but the print area was somewhere around 3 feet, maybe a little bit more. But anyway, not something that we wanted to spec for the final version. We just wanted to see if it worked, and it sure does. So those guys at Autodesk are geniuses, and this is going to be fun to continue developing and get a product out where you could buy a 2 gantry. Now, let me explain why I say 2 gantry. Well, the biggest payoff in the Escher printer is when you add from 1 to 2. You add 1. It's not quite twice the speed. There's still some weighting going on, so you don't double or you don't cut your print time in half. It's a little less than half. When you add a 1/3, it doesn't go 3 times faster. It goes, like less than 3 times faster, but it actually has less because it creates more weighting. There's more printers, so there's more weighting involved. So you start to get a point of diminishing return. But when you look at the overall print time, imagine when compared to a single printer trying to print something 5 feet long and 6 inches tall. It would take one printer forever to print that. So when you have multiple gantries, you definitely see a huge payoff in print time. And print time is that one thing, like I said earlier, that has kind of been elusive. How do we make these things print faster? Well, there's definitely trade-offs in this type of machine. The trade-off would be cost. As you can imagine, this is going to be an expensive machine. But I want to show you, we took this one, and then we did another beta to kind of show what our design style would be in the printer. So I want to show you this next printer, but it's not going to look exactly like that either. I do a lot of prototypes. It takes me a while to decide on what things need to look like. Dave, do you mind helping me lift this off the table? Yeah. Let's move these down so they don't bump. By the way, I disconnected the rail there, so that's why they're floating. Anywhere's fine. And let's help me get this one. Actually, let me just do this myself. All right, so since there was a license for two, a free, you can use two printers in NetFab and not pay anything. They allow makers to use a two-headed printer. I wanted to see what it would be like to get a benefit from two print heads and not have the cost involved. But it's really designed for people that are doing manufacturing. So one example is people that are doing packaging. So they have to make molds for like this cardboard slurry that presses in, and like that egg crate style stuff that you see in the bottom of like real heavy items. And those they could totally 3D print, save a lot of money. But we want to be able to print a lot faster instead of wait for weeks for something to be farmed out to some shop. You could make it in-house. So anyway, I wanted to see what a maker might choose, and this style machine is going to be, it's thousands of dollars. I mean, it's not cheap. But it would bring a new superpower that we've never really had before. Print times that are so much lower than what we're used to. So anyway, this was the next beta. It's really pretty. We put these screens on the front. We were considering for a while doing some really fancy stuff with the touch screens. I'll probably drop them. People that are going to be operating these printers are people that will be very comfortable with modeling, slicing, dialing in their settings, and the stock Pro with the touch screen and cloud and all that is really a bad fit for that type of a person. So this was just, again, to show we'll probably change everything about this. So it's kind of ill-fitting, some of this stuff. If you were to put this in an enclosure, one thing about our Simple Pro is that, it kicks out the back, so now your enclosure has to be bigger. Very likely this will be, yes, cantilevered. In other words, an arm sticking out. But I'll probably not have this be a sliding interface here. It will be a rail that stays there and the head will move. So it's lighter weight and we can reach out even further because 6 inches is not enough for something that you're going to pay thousands of dollars for. But it does have a similar build platform as the other one, a little bit smaller. I don't even know if it would, well, it looks like roughly, oh, it's almost. This would have to be a little bit smaller if you printed it on this machine. But what's cool about this is if you have a large platform like this, you could totally just add a third printer. Now, here's what will be bad news for some. Two heads you get for free in NetFab. So go to Autodesk, check out NetFab, and look into their this software, and check out the Escher printer. You can see what companies, you can see PrinterBot is on the list in the drop-downs of the software and stuff. So we're getting ready to release something to the public that they can start to play with. But we'll have a 2-head configuration and likely a 3-head. We don't want to go to 5. It just gets exponentially more complicated because imagine you have to home down here, and then it has to spread out to the right area, and that overlap is a bit finicky. So you have to set up all of these home positions. It's involved. But what I love is they're innovating and trying to bring the overall time of a huge print down. So anyway, this is another beta of the PrinterBot Escher. We'll start working on this full-time after we kick out. We've got some prosthetic printers that we're building right now and some final design stuff. There's always changes. And then we have something that's going to go to Nepal, to a hospital there. I think I've mentioned it before, but it's a prosthetic printer that will be taken apart. It's like a partial kit, and so the legs will be just straight up extrusion, and that will have a big print area, very tall, 24 inches on the Z, intended to flat pack. So I've got some design work to do on that. We also are working on another secret project I can't tell you about. I'm tempted, but I'm not going to. That's another kind of innovation that some of you may have seen other companies do. But anyway, we're working on a little secret project, but this is definitely in the queue this summer. We're going to get something out there, designed. And now that it's public, in fact, Autodesk even uses renderings or pictures of this printer in their presentation when talking about Escher. So we're really proud of what they've done. Happy to be on board and can't wait to get something out. That's pretty much it. It's a teaser. So I'm going to move this. Okay, if you've got questions, start asking. But I want to read an email from, well, I don't know if it's an email. It's something that came from John Betts. Thanks, Dave. I just wanted to add a sincere thank you to you and everyone at Printerbot. Well, thank you, Dave. You've made a fan. Your products have opened doors for me, inspired me, challenged me, and allowed me to develop a passion for 3D design and printing. Please pass this on to Brooke if you can. Indeed, he did. He can. I started out using a roommate's Simple Metal. Then after using some other machines at my local makerspace, I purchased my own Plus. I love that machine. Of course, the troubleshooting and tinkering are fun. What? Troubleshooting? You had trouble? Trouble with the 3D printer? Tinkering? Anyway, but I love that it allows me to pursue my engineering ideas at home to create functional products and prototypes. It's such a solid machine. After seeing the Smalls announcement video, I immediately ordered it. Well, thank you. I need to write a letter to John Betts. Let's see. Yep. I am in the early stages of building a side company centered on 3D printing and have used my Plus to bring to life many original designs for my main career, documentary cinematography. Awesome. I love documentaries. And to top this off, my dad just purchased his first 3D printer today, another Smalls kit. I couldn't be more thrilled to continue down this path and share my passion with my dad through your American-made products. I think I can safely say that Printerbot has changed my life. Oh my gosh, dude, that is like so humbling to hear stuff like this. Or at least open the door to a new and exciting phase. Sincerely, thank you and keep up the great work. Well, John and others like you, thank you guys so much. It's really crazy when at Maker Faire, I got a visit with a bunch of people, and I always ask, what are you doing with your printer? What are you doing? And it's more common to hear people, well, I learned design, which I think is the superpower that unlocks 3D printing. So download Fusion 360 or some other package that, whatever it is, SolidWorks. There's some open source products out there that, I can't remember the name of the one, but anyway, a 3D design is a skill you will need if you want to get the most out of your 3D printer. So learn that. And if it sounds complicated, well, it kind of is, but it's totally something that you can do. Anyway, so I talk to these people. I ask, what are you doing? Well, they're learning design. Some are starting side businesses. Some are doing 3D hubs and just making a little money to pay for their filament and kind of support their habit. Maybe with their wife. A lot of guys, although I was meeting more women, which is exciting. But maybe your spouse is looking at you like, what are you doing, you geek? 3D hubs or something like that where you're doing side work for somebody, getting a little money to pay for your addiction. I think that's pretty cool. But anyway, thank you, John. Keep those emails coming and feedback. Someday we should have like the worst, like the hated, like somebody that just hates us. Let's read one of those letters at some point. We might get, not to laugh at people, but sometimes it is a little bit comical. I think one time, Dave, you remember that one that kind of takes the cake? That one guy that was like, you've ruined my life.
Oh, yeah, he lost his home because of it.
Oh yeah, he because of something that we did or didn't do, I don't know. The printer, he had so much trouble and he devoted so much time. He lost work. Was he fired?
I think he was going to start a business
Oh, okay. He was going to start a business with a printer. He had no experience. He ordered a printer. And anyway, the short story was he wrote and told me that I ruined his life. And I think his kids, his wife left him, his house, he lost his house. I mean, these 3D printers have an impact, both positive and negative, apparently. Anyway, keep the letters coming. We'd love to highlight one. So, one other thing, and I'll take some questions. How are we doing on time? What time is it? It's 4:54. That's beautiful. All right, so I like to talk products. I don't have a Smalls here today. I've talked a lot about the Smalls. Oh, by the way, my daughter got married last week, so I apologize I wasn't available last week. That was the rehearsal dinner. But I haven't heard from her, which is good. No news is good news, I guess. They're on their honeymoon. They're going to move to Indianapolis. But the wedding went off without a hitch. It was a good time. Really nice to take a few days spend with family. Sorry I missed last week's show. Anyway, we're back. I like to talk about products. So this is cardboard. It represents some prototyping that we're doing for the flexible bed. We now have I think I told you a couple weeks ago, the Pro heated bed with the flexible plate even is available for purchase. And I like it so much because I hate getting things off the print bed. You saw earlier, I had to have Jeremy use a little tool to get this, and I still haven't got this other one off the bed. When you have a flexible plate that you can just take in your hand, this is the size of roughly the size of the Simple Pro, and just bend it with that PEI on there. It had a heated bed, and it pops off. It is so nice. So we're building models of that flexible bed for our legacy printers. I say legacy, older models. So this one happens to be one for, it's not the final design, but it's one for the Play with the extended bed. We're shaving off this little thing here. And, we can't make a product that one size fits all because we've got all these upgrades. And also some people have heated beds, some don't. So I just wanted to make a simple, flexible plate for the majority of our legacy products that bring the benefit of removing the print off the bed. So you could actually use this on a cold bed, in other words, no heat. It's great for heat as well. But the Pro had this really fancy, magnets that stick it on and everything. We're going just simple, old school with these other sizes. You may have a heated bed, you may not. But we didn't want to add more thermal issues by putting magnets underneath, especially when the heat bed is way down underneath the Mic 6 platform. And then you put some acrylic in with magnets and then this on top. It's too far away to keep the heat consistent. So this is these will just be simple, flexible beds for legacy bots. And you will attach them with regular old binder clips. You'll just attach them to the Mic 6 or whatever your print bed is. And you can cover it, if you've got no heat, you can cover it with just painter's tape, whatever you're using. You do have to recalibrate your Z, because the sensor responds differently to spring steel. But anyway, so we're very close to producing these. So watch our store. This is the Play with extended. This is the Plus. Just very plain because there's no screws on that one. We are shaving this to a square, and you'll put binder clips on. And this is the Simple, with or without heated bed. So the Simple has 3 different styles of print surfaces that we've done over the years. And again, we're cutting off these little handles on the end. And there'll be one extra hole so it fits both the stock Simple and the other upgraded beds. I say upgraded, they're just different. The Mic 6 is definitely an upgrade. But anyway, so we've got those flexible beds. Had people asking, are you going to do flexible beds for the other printers? The answer is yes. We are not going to have that magnet system because it creates a lot of problems. There's a lot of issues. But if you don't mind clipping this to your bed, that will work. Other companies have come up with polycarbonate. They basically slap polycarbonate down a laser cutter, cut it, and charge like 30 or 40 bucks for it. That's ridiculous. This is real spring steel. We're learning that spring steel, when water jet, does have a little surface rust, so we're learning how to oil those and protect it. Maybe even we're looking into not anodizing, but plating zinc plating perhaps. Anyway, we're looking into what we can do to make those even better. May drive the cost up, but for right now, the Pro flexible bed is available, and the other ones are coming. All right, let's take questions. Would Brooke consider a matching Core XY kit as a unique limited edition Smalls? Other than the extruded rails, you probably have all the parts. I have considered using I basically went through my parts bins and designed the Smalls from existing equipment. I will consider that. I'll tell you more than Core XY. Some people like Core XY. Core XY is, if you don't know, I don't even know if this will help, but it's kind of interesting. You've got these belt loops that go around to two motors. The motors sit here, the belt loops come down here, and then they actually go across the gantry and hook to the two sides of the extruder. So when it pulls the extruder around, you got all these belts running everywhere in this H pattern, and intentionally it's supposed to be lightweight gantry, because you don't have to put a Cartesian bot has one big, like let's say it's X gantry with a motor hanging off of it. So this big motor is inertia, causes problems with inertia if you're going super fast. So Core XY puts stationary motors off, mounted hard to the platform, and then it just uses belts to do this fancy trick work. You actually have to cross the belts at the back, and so it does this weird thing. And so the gantry remains light. The reason I'm not really into Core XY is a couple of reasons. You have really, really long length of belt, especially on a big printer. And that belt can stretch. So that you have to get those belts so tight in order for your corners to be sharp. So I tend to go to what's easier, Cartesian. So I don't mind hanging that in the prosthetic bot. This is what I did. I don't mind hanging one extra motor off on the X gantry and just sliding that back and forth, because I believe the truth about 3D printing is it's slow. It's not going to move at 200 millimeters a second. If you've ever seen somebody actually print at over 100, 150 millimeters a second, there's trade-offs. And when you move, it's just like a race car. If you want to drive 200 miles an hour, that is light years above like 60, 70 miles an hour. And problems can happen. So in order for it to be a lot more straightforward, I like Cartesian. Now, that said, Cartesian, I have built some Core XY bots, by the way. So I do have some experience with it. And I've seen some that have great results. But again, a little more finicky to maintain. This Cartesian style on top with a dropping Z is what has me interested in maybe taking some spare parts and making a more traditional microwave oven or box style printer with spare parts. But I'm really not going to make any promises. I like the Smalls because it is so small. And if you make it a box that's like this, it's not Smalls anymore. It's Big Box. In fact, there was a printer called Big Box, I think. Anyway, E3D. Anyway, so I don't like how much room they take, but I do like how straightforward the Z is. The Z the platform starts up here, and as it prints, it just drops. So the Z banding, you don't have to chase any resonance. But anyway, I've considered it. What I'm more interested in is with my spare parts is maybe an inexpensive CNC platform. If people want to do very, very light, like with a Dremel, little milling projects or something like that. That's probably what's going to be on my plate this summer, to kind of kick out some designs to see if I can get a compelling, very small, inexpensive little CNC so people can learn about CNC. One thing about CNC, though, is you do have to put it in a enclosure if you want to make it useful in a classroom. And I'm always thinking about kids and schools. So I'm happy with the Smalls right now. If somebody else wants to design a kit based on those parts, go for it. The kit's cheap. What else we got? Are all printed parts made with PLA on the Smalls? Yes, right now they are. Black PLA. I've considered PETG, which has kind of replaced ABS for the filament that is really good for durable parts at a slightly higher temperature. But yeah, it's just PLA right now. We do publish those parts, so if you did get PLA and you're not happy with them, you want to do ABS, you want to do whatever, polycarbonate, whatever it is. I guess you could do nylon, some different types, but we're going to leave that up to you. We're trying to keep it cheap. PLA is cheap. And that concludes our question and answer session. All right, so there it is, guys. Printerbot Live. What is the date? I don't even know anymore. What's the date? 15th. June 15th. My kids are at home, out of school. Oof. You know how that is. The summer is going to be fun. I've got lots of projects for this summer. We'll have lots to talk about every week. At some point, I'll take a vacation. I'm not sure when yet, but we're really glad you guys came back after a week hiatus. So welcome back, and happy printing to you. We will see you next week.